Is it fine? So we can start our class now. So today we will do modeling on the protein Mycobacterium tuberculosis. Okay. So let me go for Uniprot. So let's open Uniprot. So I just want to show you something, any one of the protein. Okay. I choose some P9WJI7, the protein ID. Okay. This is the ID. It belongs to nicotine phosphoriblar transferase. It belongs to Mycobacterium tuberculosis. So it doesn't have any structure. So let me show you, there is no structure here. Okay. So in that case, we want to choose the blast analysis. We have to go for blast analysis. So before we are going to the blast, let me save this FASTA sequence. So I have to save the sequence. So just note down this numbering also. So let's create one folder, as we created yesterday one folder here. So let's create one folder here. The folder name was HM2. Let's create a desktop the text document and save it. And I need to run as I need to find a similarity sequence for this particular protein. So let me find blast analysis. So let me do blast for this particular protein. I'm running the blast. So let's wait to the similarity. So we have got something, the similarity sequence. Okay, we found a similarity sequence with more than 37 percentage identity, and remaining all are 24%, 31%, 30%. So we can choose this particular organism, that is Enterococcus fecalis. Okay, let me see that organism. So it is also called as Enterococcus fecalis. Okay, so let me see, we can also choose directly from here only the PDB sequence in this structure. Okay, there are two structures are available. Okay, so two structures are available. So among that, we want to know which structure is very similar to that particular protein means. So you can also perform, if one structure is available, if there is one PDB structure is available, you can choose one structure. Okay, if there are two or more structures are available, we don't know which is more similar to that our uniprot sequence. At that criteria, we can go for blast analysis. Okay, let's go for blast. So I do the blast P here. So everything is similar as what we have done yesterday. Okay, so I do here run, we choose here the protein data bank, and we write here enterococcus fecalis, right? So let me run this blast, we will get output among these structures which is having the most similar one. We will find it. So let's wait for another 2 minutes. Yeah, after completion of the blast, we'll choose a PDB ID. So which is having the best one. Just for a cross verification, this is we can also choose from there itself from Uniprot only. But I am doing blast for just for cross verification, which is having the best one to choose the best version in Enterococcus. There are two sequences are available, two structures were available. That's why. Are you understanding what I am saying?
Yes.
Yeah. So let's wait. It's running, still running. So results were came. Let's see. So the results were it has only one structure with Enterococcus faecalis. You can see this is very more similar with that particular sequence. Are you able to see the difference? The 2F7F here is also is available 2F7F. It also belongs to A chain. Did you find it?
Yes, sir.
Mhm. So this is the purpose I was waiting to find which was having the best one. That's right. Okay. So blindly we can take now 2f7f by typing in the Google. Just type here 2f7f. Just take the file. Just click this one. Okay, and download the FASTA sequence and download the PDB format. So I just take this both. Uh, I just take this both files and I'll incorporate in my folder. I will take only the FASTA file right now. Okay, after I'm taking the FASTA file, I'll paste here to for making alignment for doing cluster X. So let me save in which format we need to save. Please may I know from your side. So which,
Alignment.
yeah, which format we need to save? I think it's in FASTA, right?
Yeah.
We need to save in FASTA file format. Okay. Okay, I saved in FASTA file. Just closing these all things. It has been saved in FASTA file. Let me open the cluster X. Okay, go for cluster X. Just open. Go for the desired folder. HM2. Select. Okay, and go for alignment. Select the output format option. Select all the output files. Okay. After alignment, go for alignment. Do the complete alignment. So whatever files you have selected, it will generate. Is it clear? And after that, do save sequence. I have saved. Let me see whether those are all generated or not. So I think all were generated. All files were generated here. Hmm? Fine. All files were generated. So we need only PIR file. If in case if you want PDB file, then you have to make it as write alignment as PostScript file. So let me close this file. So it has been generated. If you double click this one, if you have a PDF Adobe Reader original version, it will open. Okay, and I am just opening this file. Okay, let me remove the unnecessary things. Okay, we need only this header. Okay, now what shall I have to do? What shall I have to write here? Can
First,
anyone?
sequence.
Yeah,
Sequence.
yeah, fine. Sequence. How
Column.
many how many columns?
9 columns.
9 columns.
1 2 3 4 5 6 7 8 9. Okay, what about here? What should I have to note? Because we have taken this PDB. PDB is a structural database.
Structure.
That's why we have to
Structure.
note down as
Structure.
structure. Yeah, structure X. And also the same 9,
9.
5, 6, 7, 8, 9. And what we have to do the first column?
Name of the sequence
Yeah,
protein.
ID.
Yeah.
We have to make it ID name. And what is the ID starting from? It's starting from first,
1.
right? And it's A chain. It belongs to A chain. It's ending from
4, 6,
463, right? And what
2.
about the ending? Ending is also A chain. And
Yes.
resolution is default. What shall the resolution be?
1.002 2.0.
Yeah, that's right. Fantastic. And what about here?
Sir,
Name of the
Yeah,
PDB.
sir,
yeah. Go ahead.
sir, that 1A463 that I couldn't understand, sir.
Which one? One.
That 1A463 that
This
number.
is just a starting chain, starting residue num. I'm saying
Hmm. How do you find it out, sir? Like,
it will be in. It is always default. So this is how I find it. You are asking. Okay,
hmm.
I just show you this one. Can you see here the sequence? This is our P9WJI7 sequence. So it is starting from 1, it is ending till 463. Got it?
Yes, sir.
Now is it clear?
Sir,
In case
-1, -2.
those are resolutions, those are called default resolutions we are giving for protein visualization.
Okay.
Those are default, always default. Okay.
Okay.
So let me open this one. So I don't know what is the sequence starting from where. In case here it is not starting from 1 or 2, we need to find, we have to open 2F7F PDB ID in word format, then only we can able to identify from where it is starting. Okay, I just open with a word and we'll find out. So let me come here the down. So where it is starting?
4.
Note down this one please, and at the end also we'll find it has only one chain, that's why we need to find it to get down. So till where it is ending? 485, right?
Okay.
So it's starting at a fourth residue and it belongs to A chain. Because how I said A chain? Because you have chosen only A chain here. See, we have chosen A chain. Got it? So I am giving A chain. And what was the ending chain length?
485.
485.
Sir, after 485 also it's A chain, no?
So these are A chain, but these are
But
heteroatoms.
okay.
Got it? These are heteroatoms. Means these are ions. Some are ions, some are water molecules, some are ligands. Okay?
Okay. Okay.
We will also incorporate these things. Okay, we will do this one also. I'll show you today the difference.
Okay.
So this was A chain, and again the default the same. Okay, now everything is completed. Yesterday we have done one procedure of homology modeling till here. Today we need to edit the missing residues also. Okay, we want to edit the missing residues. So let me see the missing residues in the PDB file. So just type Control F, give missing. So did you find it the missing residues still here? There are some missing residues. There are 1, 2, 3. First 1, 2, 3 there are some missing residues, and later 486 to 494 there are some missing residues. So it is very easy to identify the missing residues of 1, 2, 3 because it will be in starting only. Okay. So let me see methionine, aspartic acid, tyrosine. So it is available or not? It's available, right? Methionine, aspartic acid, tyrosine. Got it? Those are missing. So we need to make it as a defaultly we need to remove them. So after removing, there is some need of gap is there here. Okay, so we need to fill that gap. So for that sake we are giving gaps 1, 2, 3. So now it is matching, right? The alignment is matching. Got it? After that, sir, it is very difficult to identify if it 1, 2, 3 means it is available in starting only. What about, sir, these all things? It is starting from 486 to 494, and how do I identify? So you need to understand why, sir, this missing residue, these all things were came. So see, our crystallization is ended till 485 only. Our crystallization has started at fourth residue, but why 1, 2, 3 are not available from crystallization? Because those are experimentally were missing. That's why we are removing them. Okay, got it? What about ma'am? Kasturi ma'am, Sampada,
Yes.
Harvin, are you
Yes,
getting
I
what I'm
got it.
saying?
Get
Is it clear the doubt what I'm saying? Because I'm not
yeah.
going directly. I'm just explaining everything from step to step.
Yeah. Getting.
Okay. So see, now 485 has completed. We need 486, 487, for these all things. So where 486 is starting? Let me see. So to that criteria, you have to note down these all things. Okay. So you have to note down the IDs, whatever I said. Okay, so so just give me the control F. Let me find the first three residues. It will be very easy for us to identify the remaining things. So what is the code for leucine? It is L. Okay. What is the code for threonine? The single letter codon was T.
T.
Okay. And what is the code for glutamic acid? It is E. Right. So now we need to find LTE. If you find LTE, it is very easy to find the remaining things. Okay. So let me go for here and just see. Go for control F, just go for LTE. Okay, we have given three things and just giving enter. So did you find it? LTE, it's available or not?
Yes.
It's available. See, just before the LTE there is histidine. Okay, H, histidine is available. So histidine is 485. Let me check whether that is histidine or not. We can also clarify the, we can able to cross verify that one also. So it is histidine 485. Got it? It's there, right? So it is there histidine. After that only L, T, E, T, V, and K, E is there. So blindly you can remove these all things. So blindly you remove these all things, whatever are missing. Okay, I removed. I am making as a gap. Is it clear till here?
Yes.
Arvind, is it okay?
Yes, sir.
Sampada,
Yes, sir.
You are actually removing the LTE, right, sir?
I want to find all the 9 residues because to not get if I remove all those things it is very easy for me, but to understand you people I made it to remove only to identify the first 3 digits. Later digits are similar na, all are in chronological order only from 486 to 485 495. That's why I removed while showing the first 3 things.
Okay, okay.
Okay. uh, So now I have removed all those things, but I also want to incorporate the substrate. Okay, what is the substrate? What you are saying, you may have some doubt. I want to incorporate these things also. I want diphosphate, I want nicotinic acid also, sir. These are very important in my protein. I want to incorporate these things in my template sequence of uniprot also. These are things are not available. So if you want those things, then what shall I do? I have to make sure these things I need to include there. So let's go here, let's go here. Okay, I want sulfate. If you want sulfate, but sulfate is a ion, it is not useful. So just blindly you can remove the sulfate. Okay, just remove the sulfate because there are many sulfates are available. So just scroll down like this. I have removed the sulfate. Okay, oh still one more is there. And there are 2 nicotinic acids are there. Okay, so only one nicotinic acid is enough for us, no need two, because what I am doing here, just go to here to come down, get down here, just remove it. So now there is a diphosphate is available in 701 and glycerol is also available. So let me show you the glycerol also. Its glycerol is also available. I need these 3 things to be incorporated. What shall I do here? I just go here. See, I need to save the file which I edited. Okay, just save this file. Okay, it has been saved and close the file. After that, there are 3 things you want to incorporate. What are those things? That is diphosphate, other one was nicotinic acid, other one was glycerol. Because you need to mention 3 dots if you want these 3 things, that is diphosphate, nicotinic acid, or glycerol. If you want nicotinic acid itself, you can give 1 dot. If you want 2 things like a glycerol and diphosphate, then you have to give 3 dots. Okay, why these 3 dots does tells us that some ions, some small molecules are there. You just read them and you have to make sure when you are modeling the 3 dimensional structure, those things also get modeled. Okay, so what I'm doing here, I'm giving 3 dots. So 1 dot here, other 3 dots, 2 dots here, because here after this one there is no sequence is there, that's why I'm ending here itself. Okay, and here also the same, you should not give this way. Okay, and I'm also giving here one dot for the nicotinic acid, one dot for diphosphate, one dot for glycerol. Okay, is it clear till here?
Yes, sir.
So
Can
later
you
what,
please repeat once again, sir, why you are keeping that dot?
why I'm keeping this dot, you want to, you if you want these ligands, then you need to keep dots. How many ligands if you needed, those many dots you require to keep. Okay, if you don't want these things, you no need to keep any dots, directly you can go for modeling. If you need any molecules, small molecules, if it is required for your small molecules, if you don't keep small dots, the small molecules never comes in your three-dimensional model.
Ligands means which one you are saying, sir? That oxygen molecule, sir.
Which one? What?
Ligand means which one you are saying? I don't.
These are ligands. These are ligands. Nicotinic acid, diphosphate, sulfate ion. These are ligands.
Okay.
Got it?
Yeah, yes, sir.
Okay.
Sir,
Now,
but where will those dots occur?
why? What?
Where will these small molecules occur if we
In
are
your PDB
putting those
file.
dots?
In your PDB file itself, it is available. This
No, sir.
PDB file. No.
I'm asking in the modeling. In the model, we
Hmm.
are doing this modeling, right?
Yeah,
So
yeah.
we are if we put those dots at the end,
Hmm.
then where will those dots occur
Oh,
in
that
the
one
model?
you're asking, right?
Yes,
See,
yes.
for example, we we are modeling for our uniprot sequence purpose. You want to see those things in our uniprot sequence, but those are already available here in 27F7. So let me click and show you this one. So if I click this one, okay. So let me show in cartoon representation, then it will be very easy for you. So I made it like this. Okay, I am also making it is a chain. So go for display, go for sequence, so drag it at the end. Okay, if you drag at the end, you will find something here. Can you see here?
Yes.
Can you see the nicotinic acid? Can you see
Yes.
diphosphate? Can you see glycerol?
Okay.
We need to find in our uniprot sequence also the same thing. If you click here, there is a dot here. So let me make it as stick, or let me make it as a ribbon, something like, and hide the cartoon. So can you see now the stick?
Yes. So it will automatically get added over there.
Yeah, it will add it over there now. Okay,
Okay.
if it
Yes,
is
yes.
there in, if it is there here, if it is not there, it is not required to keep a dot. Okay,
Okay, yes, got it.
after you are keeping the dots, now we have added 3 dots. Okay, actually our structure is ended till 485 only, right? But we have added extra 3 dots, right? So that's why we need to keep it as 3 plus 3 we need to add for 485. If you are adding single, you have to add plus 1. If you have added only 1 dot, then you go for 1, you have to add one extra residue. Okay, it is ending till. If you are adding 2, go for 487. If you are adding 3, that's why we are mentioning as 488. Got it? And here also you have added 3 dots. Actually our sequence is only 463, but we have added extra 3 dots because we are asking, there are 3 more small molecules are available, please add them, include them also to read, we are asking. So that's why we have added here. Got it?
Yes, sir.
So now you need to save as in dot ali. Okay, I just saving the ali file format, saved it. So let me see ali file format has saved or not. Yeah, it has saved. Now there is something was missing. What? We need a Python script. Okay, so it is required to make Python script. So yesterday we have downloaded one Python script, right? We know that one, that is available here. Previously it is available here. You can find there, here it is available. Okay, you can able to keep this file there. Okay, directly you can give there, or else you can, or else if you need that file, I can able to share to you. I have already one file is available, so I can able to share to you this one. So I just paste here. Okay, we need to edit this file now. So I already had given the default file here, that is known was 2f7f, this one, and the id was p9wji7, and the alignment file was ttali. Just take this ttali file format we are seeing, and we need only something called 5 models. So just save. Okay, is it clear?
Yes, sir.
Yes.
Sir, sir, one doubt, sir.
Yeah,
This script only I doubt, sir. Like, how did you get this one? You typed it or is it available?
yeah, it is available in the here itself. And if you just go in the Google, just type as tutorial. Okay, tutorial Andrej Saheli. Okay, if you click this one, you'll find here something. Okay, let me
So it
type
is
like this one.
address Sally.
Homology modeling. If you give, it will also get. Okay, just give Andres Sally. Okay, tutorial Andres Sally. At the end, if you come, you will find the script. So it is available here is already. Okay, you just copy down and give the dot extension as .py, whatever name you are giving. Hmm?
Okay.
So always it should be ended with, it should have, when you download the script itself, when you save it in .py, then you will get this Python file script file in this format.
Okay, sir.
So now what I'm doing here, I'm going for here. I have saved already the file. Go for run the module. So see, I'm running the model. So Python is running. Can you see the models are generating now? So just observe it. What difference will be seen here? For our P9WJI7 also, we can see those 3 dots also. So 2 models were generated. So remaining still 3 models we need to. So 5 models were generated. Let me see which is the best model. So I think the best model was 49.705. The third model was the best, right?
Sir, can you tell me what is dope score, sir?
Discrete optimized potential energy score.
Can you define it, sir? Like what it will do? Like
It never does anything. It's just a scoring name. That's it. So it calls a dope score. That's it. It has been abbreviated in dope, but the abbreviation is discrete optimized potential energy. It's a what it does. It just generates a score in the potential energy values. Do you know the potential energy values? What potential energy says? How far it has been modeled? All the 5 models. How far they are? Which is having the best model? It shows.
okay,
Okay. It's not like anything else. It's just a modeling score. That's it.
okay,
Okay. And you just take this screenshot. And the third model has the best model. So I just click this double click, and you'll find. So it is not 27F7. It's our model. That is P9WJI7, which is the modeled one. So let me see. We have given 3 dots. It has came or not? Is it there? It's available.
Yes.
Yes.
So let me hide the lines. So it's available. So let me sticks. So let me label this one. So I'll label it. See, after I'm labeling, it is showing that nicotinic acid. It's a nicotinic acid. Okay. Let me add one also. Let me add this one also. Let me label. So I have labeled it. You can also hide them. Not an issue. No problem. And this is the model which we have generated. The second method of homology modeling. Okay. I think this is not available in YouTube also. Till now it has not yet uploaded. So don't go for YouTube. Just find our recordings. Okay. So this was the model we generated, and also we can also see the substrate also. Let me show you the substrate. Let me see the substrate 4 Armstrong region also. So it is there here. So let me label that one. So it is there. Let me see the 4 Armstrong region of that one label. So label it. So now it finds. Can you see now? This is the pocket chain what we have incorporated. We need this pocket chain to make dog with that small molecules ligand. Is it clear?
Yes.
Yes.
So this is about today's class. So if you have learned something new, if you feel this is a better, so that's if you learn that makes you happy. I think so. If you learn this one,
Yes, sir, definitely.
these all things, okay. That then
sir.
it make you satisfied. Yeah,
Sir, just one doubt, sir.
yeah. Tell me,
Can
Arvind.
I just explain that one, sir? That Serene 184, that marking how you did, sir. This names and all.
Just just go through the recording, Arvind. That's nothing else. You can able to see these are action. This is show. This just show for cartoon representation purpose. Okay. If you want to see the this serine, all these things means you just click here the particular region. Okay. Click this particular region. Go for action. Okay. Go for modify. Go for around 4 Armstrong region. Now if I select, everything goes. That's why I'm not going there. Okay. When you do while watching this recording, it will be you can able to do it. Okay. After labeling these all things, go for label the residues. Go for L, label the residues. Okay.
Yes.
After that, go for color. Go for these things which you want. If you want yellow color, if you want cyan, or if you want orange, if you want line gray tints, anything. So if you want green also, you can make green. Now is it clear?
Okay, sir.
So this is how we represent a model, and these this type of models are deposited in our pdb pdb. Now we can able to easily deposit it here. So if you send to the pdb, they will deposit here. They will give some id to this particular protein that will be published. This is the way of constructing a homology model. Is it clear?
Yes.
Sampada, what about you?
I also got it. Sir, I just wanted to ask what is pocket chain exactly? I didn't get it properly.
Do you know competitive inhibition?
Yes.
So let me show what is pocket chain also. That will able to create you don't have any doubt on that particular topic. Then I can show you. Okay, after I'm going here. So can you see there is a lock? This is a total protein. We have
Yes.
created some pocket chain here. This is the key. You have some drug. Okay, some drug like some ethanobutol or streptomycin for mycobacter tuberculosis. You want to see how far it is fitting in this particular pocket chain. So we need to identify in this particular chain where is that particular pocket chain is available. What are those residues? So this pocket chain goes and binds at this particular place. Okay, that is
Okay.
called pocket chain. And
Okay.
you can also see that representation. See how the docking goes and binds to the target, to the complex. That's the thing. Another thing was, which if you give three or more ligands, only one goes and binds to the pocket chain. Finally,
Yes.
that is called docking. That we
Okay.
do in our next week section.
Yes.
Is it clear then? If it's clear, it means I just stop presenting. If you have any doubts, you can stay back, or else you can quit the class. I think it's clear, right?
Yes, that's clear.
Yes.
Everyone,
Yes.
is it okay then?
Sir, I just wanted to ask that
Hmm.
whatever we open in that PyMod, we have to first, I mean, do all this procedure what we did today, and then
Yeah,
only
if you
that
want to
PyMod.
visualize any protein, if you
Yes.
modeled any protein, then only you can able to visualize that model protein. If not, also you can download any protein from PDB and you can visualize.
Okay.
Okay.
Yes.
Yeah.
Because I wasn't there on the very first day of PyMol when you did that,
Okay, no
and
problem. Once you just see the videos recordings,
the video actually you recorded it later, so that's why I couldn't,
no problem. Now whatever I showed you, those things are same. You have recorded everything. Okay.
Okay. Yes, sir.
Even I teach you once again. After we will give you 1 week time to practice everything after
Okay.
our section, after our
Okay.
classes. Then later, if you have any doubts also, at that one day we will have one topic on Python once again. Okay,
Yeah, yeah, sure.
we will clear everything. Don't worry,
Okay.
you have not even missed any classes. Don't think like that. We will teach you.
Yes,
Hmm?
yes, yes.
Yeah, fine.
Thank you. Thank you,
So
sir.
then, if it is cleared, okay, we can leave. Okay.
Yes, sir. Thank you.
Yeah, fine.
Excuse me, sir.
Hmm.
So, if you don't mind, actually, what I had done, will you please see and will you guide me, please?
Yeah, yeah. You just open that one.
Hmm.
So the recording is on, I guess.
No problem, no problem. It will be benefited to you also if I say this thing. If you forget also, no?
Yeah, yeah. Okay.
Mm.
Is it okay, sir?
Yeah, you have to share the screen. You open the file, what you have done.
Uh, can you see my screen? No.
Yeah, I can see.
Hmm. So this is the protein of unknown structure, which I have
Hmm.
searched for. You don't have structure, no. First,
Hmm.
I
Perform
take
blast one. Hmm. Go
yeah,
for blast.
I took the sequence
Hmm.
and pasted. After that, went for blast.
Hmm.
Mm, um, what the sequence of this one? I took this one. Will I do now, or else will tell you what I had done? Excuse me, sir. Hello, hello, sir. Can you help hear me?
I mean, I'm not getting what you're doing. How do I help you? I just can able to see your. I can't access now.
Actually, I'm saying will do once again, or I should tell. I will tell what I had done.
No, no, no. What was the error exactly you are getting? That show me.
Yes, yes, here the unknown one, no? I
Hmm.
came here and took the sequence and pasted on a word. After that, went for blast and
Okay.
took this one from PDB.
Go for the folder. What you have done.
This is the folder.
Okay. And open the ALI file format which you have edited. Open with Word.
Yeah, it's it.
See, the after structure X, you should not give more gap.
Okay. Yeah.
And also everything is okay.
Mhm.
And what about the alignment? Have you found the missing residues here?
Yes, sir. Also done. This
Done.
four starting five, I think, five. I
Okay,
done.
then save it. Save it again. Save it in TTALI. Save it in TTALI.
Sorry, in EDLE.
TTALI. Save it in TTALI format only. Now you have edited now. That's why
Yeah,
the
yeah.
structure X you have
Here
edited.
only I have to save, no?
You have to save it. Give it in capitals TT.
Capture it.
Because you know it should have to follow all those in capital only. Then we don't get mistake confusion. That's why.
Actually, in
Sir,
the
we
starting
have to
only
give
I have given small TT only.
No problem. You give it a big TT only. No problem.
the
If
double
it is a
inverted
small
commas or single inverted comma.
string, will take double or single also. No problem. But you always go for double quotations only. Double strings.
Okay.
TTALI dot ALI.
Dot AL.
ALI.
Yeah.
Close the string.
Mm,
So give double quotations, not single.
Sir, one more I wanted to ask.
Yeah.
If the chain starts with one, then the missing ones are, I mean, the four, three. If the chain starts from four and missing first three are missing, so we have to give that number one or four.
Hmm.
Like Kasturi has given
I need to
one.
see Kasturi once, if you don't mind, can you open the PDB file also? Because what is the
yes.
starting chain, ending chain? Let me cross verify it.
PDB in the word form, no?
Hmm.
Mm.
Kasturi, one suggestion: use WordPad only.
Okay.
So if you open in WordPad, it will be very easy for you to look after where the alignment will be properly will be arranged.
Okay. Yes.
Go for down where the structure is starting from where it is starting. Just scroll down it slowly. Hmm? Wait. Get down, get down, get down. Scroll down. How to come down, come down.
So here it's showing on the left side helix seeds. What are these?
Those things are not required. Get down, get down.
Okay.
So
From
your
here.
residue is starting from 6, but you have mentioned 1.
Okay.
Note down those things. 6 it is. Okay. And later go for ending residue. Go
Mm.
quickly. Scroll down far. It takes time if you go slowly like this. You have to drag it. So when it chain terminates, just stop it. Okay.
Mm.
No, go up, go up. You have came down, 2 down.
Here. 3237.
So
I.
408, 408 it is 6
Yeah.
and 408. So
Yes.
just go your file, alignment file, ALI file. Go to your alignment file now. Just change it, those all things. You have mentioned everything wrong here. The starting and ending residue. So don't do this mistake next time. Okay. Now you can now you have rectified your mistake. Okay.
Yeah. 405.
It is 6.
Is it okay, sir?
Yeah, you can close now. I mean you
Give the
have
gaps also.
Sorry.
Gaps.
Which gaps?
On the starting, you have given 5.
One
no
more.
problem. Those are if those are missing residues, if you have done properly, okay.
Hmm. No, we'll do this one, sir. Sir, after that, we'll
Go for
do
Python
this.
script. Open Python script. Not there in the folder which is there in your folder. One which is there in your folder.
Mm,
There is a third, fourth one. Fourth one is the script. Open that one.
Open
Edit
edit
with
with ideas.
yeah, open it. Open it. Ideally. Not open. Open with ideally. Now, now just go for a run. Go for run. Not like that. Just close that once again.
Hmm.
Go for run.
Sir,
Run.
that is capital TT, right?
Yeah, yes, yes. Save it.
Once again, we'll do the run.
Go for run. Run module. So it is saying you have not installed the MGL tools. Modeler. So have you installed MGL tools modeler?
Hmm.
Yeah. There is already outside one file is there. I think you the software you have shown right now only.
Sorry, sir.
MGL tools you have opened a software tool now previously now.
Huh.
That one you can open it now. You can open that tool and just install it. And
Couldn't
then
get
you
you.
can able to run. Okay.
Actually, couldn't get you, sir.
Previously you have opened a folder.
Yeah,
There is a tool called MGL tools. Software is there.
this one, no?
Yeah. Just
We
give.
installed from this one only.
You have installed it.
From this one only. Actually, after downloading, I copied it to here only.
Have you
From-
installed?
Yeah, yeah.
Have you installed Python script also na?
Yes, sir.
Then what was the problem? Modeler, have you installed Modeler?
Yeah.
Modeler software, have you installed?
This is only, no?
Yeah.
So here downloaded, but in the modular file folder, no application file is showing, no?
What I
There
can
should be anything.
share the link how to download everything. You have to do it these things because you have to download it, right?
Yeah,
The
actually,
software, the
I have
modeler.
downloaded,
See,
no?
I show you the modeler software how it looks also. Once again, wait. Can you close the
Yeah,
sharing?
yes, yes.
Okay, I just show you my screen to you. Is it visible?
Yes.
So let me open the softwares. So can you see now? Modeler has installed here, coming, downloaded.
Yeah.
Have you done this one?
Yes, sir.
Then where is that file? You are showing the folder for me. I'm asking this file. I'm asking this file for you. Wait, it is downloading still. So if you have downloaded, you will
Okay.
find this type of file, modeler file, this type of setup. Is it clear?
Yes, sir.
So
Yes, sir. We'll
one
try
thing we do
once
it.
again.
What
We'll
I mean was
install it.
just download this one and install it. Okay.
Okay.
I
Okay.
have given you license key also. Install it
Yeah.
once again and run
Okay.
the software. Okay.
Sure.
If it is not run, we will
Yeah.
rectify on Monday. Okay.
Okay, sure.
No problem. You just try it once again. Whatever I said to you, it will run because you have installed all the softwares. You are say you I have seen, but only one thing was that one was missing. It is saying the error also. You are missing the modeler. That's why. Okay, that's why it is ending.
Okay, sir. We'll do it again after that.
Okay, you do that slow, patiently. It will come. Okay.
Okay. Thank you.
Mm, no problem. But tell me whether it is coming or not. Message me. Okay. We
Yeah,
will.
yeah, sure.
I will also know whether you are doing or not.
Yeah, sure.
Okay. Okay, fine. Then okay, we will leave. Okay.
Okay, sir. Thank you.
Yeah. Yeah.